So our problem, well, my problem for you is serialize and deserialize a binary tree. To give a
Mhm.
little context behind it, serialization is when you convert a data structure, object, or other form of data into a sequence of bits so it can be stored somewhere, like a file or memory buffer, or transmitted across a network, for example. And it has the ability to be reconstructed again in another computer environment. So, for this particular problem, you want to design an algorithm to serialize and deserialize a binary tree. There's no restrictions or any sort of like other criteria besides this. All that needs to be remembered is you have to serialize it to a string, and this string has to be able to be deserialized to the original tree structure afterward. So you can use any method you want for this. But yeah.
Right. So if I'm being honest, like the immediate solution that my head runs to, I have two immediate solutions in my head.
Mm-hmm.
The first is like it's it's to use like JSON notation and just turn this into an infinitely nesting JSON tree.
Mm-hmm.
Um, but the problem is, I think the issue with that would be it uses a lot of brackets. Uh, yeah, for every node, it would use like two brackets, so
Yeah.
it would end up using a lot of space to do that. The
Mm-hmm.
other thing is doing a in order and like in order and post order traversal, or like some combination of like two traversals.
Mm-hmm.
And then I store it that way, and then I deserialize. So the problem is I forgot how to deserialize from in order and post order, but
Mm-hmm.
yeah, but that's the second idea I have. Um, and another idea I have is like doing it the same way LeetCode does it, which is um, you basically like mention you imagine as if there's a full tree. Or sorry, you imagine if that there's a full and complete tree, and you mention uh, or basically you print the tree level by level, but you also mention non-existent trees. Sorry, non-existent leaves.
Mm-hmm.
Um, yeah. Now the problem with that is that it uses a lot of nulls. Uh, so I think what I'm gonna do is, mm, I think what I'm gonna do is I'm gonna go with that approach of like I print the tree level by level, uh, including all of the nulls.
Mm-hmm.
But I'm going to get rid of the issue of consecutive nulls by making a special character
Mm-hmm.
that is like, let's say, 3 null or 10 null that just kind of concatenates 10 nulls into a single character called 10 null.
Mm-hmm.
And that way I can deserialize. I can still deserialize it, but when I store it, I don't need to store like 50 nulls, like 50 consecutive nulls. I can just store something called 50 null.
Okay, okay. So what you're saying is you're going to do was it a level order thing you said?
Yeah. Yeah, so it
So
would be a level order traversal of the tree, including null nodes.
okay, okay, I see. And with those null nodes, you said there's going to be a special character with them?
Yeah, so uh yeah, so like let's say the array I like let's say this one in front of us, like 1, 2, 3, null, null, 4, 5, right?
Mm-hmm.
Instead of doing 1, 2, 3, null, null, 4, 5, I'm going to, so you might imagine like in lower levels, you might have like 1, 2, 3, null, null, 4, 5, null, 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 6, right?
Mm-hmm.
In that case, instead of storing like 6 nulls, I'll store something called 6 null.
Okay, I see.
Yeah.
And how would you how would you be able to discern whether or not like like certain values are on different levels when you deserialize it afterward?
Right. So when I deserialize it, I would turn um when I deserialize it, I would mm, well I could index like I can do some math to find the children of a certain, like, let's say, like take the example of 1 2 3 no no 4 5.
Hmm.
In order for me to find the left child of 1, I take its index, and then I can do the math. I can do some math to find the index 1. um, I don't exactly remember. I think it was I think it was n was it n plus, no, that was for finding the parent. Hold on
Dude, this is like
one
CS
second.
221. What the heck?
Yeah, it is. Um, let me uh, go ahead and write this out real quick.
Mhm.
Um, so 0, sorry, 0 1 2 3 4 5 6 7. So that's going to be, or no, let's go ahead and just try this. So this array, I'm going to write above it its indices. So 0 1 2 3 4 5 and 6.
Mhm.
So in order for me to find my parent, I do n minus 2 divided by 2. So that's for the right child. Mm,
So where n is the number of the elements.
yeah, so for 2, I know that my parent is 0 because 2 minus 2 divided by 2 is 0. And then I think the other one is just n minus 1 divided by 2. So if I take the example 4, my parent is 3, and I know that because I can do. Oh, that's tough.
So the way I currently do it is it's definitely interesting actually. Yeah, like I didn't it's a unique way of doing it by like using like a formula in order to determine like which one are like the null values. Are there
Mhm.
do you think there would be any simpler ways besides using level order in order to effectively do the same thing?
um, hmm. Is it that in order and post order combination?
Hmm. Well, okay. Like I get what you're saying about using like in order and post order. Like that also is a valid solution. But do you need to use like both in that situation? Or like like okay, like let's circle back to the idea you had about having like like how leaf nodes have null values. How can you use that idea along with the idea of like the traversal in order to effectively like figure out what's a leaf, like what's a not, like where like things end and begin.
Right. um, mm,
Like you on the right track with like the n, no, like the n idea, like attributing some sort of
mhm,
value to like null.
right. Yeah, or you mean like you mean like 6 null, 10 null, like that idea?
Just like the general idea of having like values for null.
Right. Um,
Yeah.
I think maybe one way I want to think about this is I want to think about like deserialization first. Like
Hmm.
what array could I give the deserialization program in order to generate a binary tree? and
Mm-hmm.
then I can think about like serializing it after, because I kind of have the serialization function has the luxury of accessing an actual binary tree,
Mm-hmm.
whereas the deserialization has to like figure it out afterwards, right?
Mm-hmm.
So I think I want to start thinking about like what structure, what serialization format would a deserialization algorithm be able to turn into a binary tree?
Mm-hmm.
Um,
Yeah, just to clarify, you can
mhm,
do it with the like you said, post order and in order, and I'm sure like if you delved into the math formula a bit, you could also solve it as well. But I'm just like thinking of like a simpler solution for this. So
right. Um, do I do I um do I do a pre-order traversal?
that's interesting. Well, what makes you say that?
Um, because if I do a pre-order traversal and I print the nodes in the order in which they're seen in the pre-order traversal,
Mm-hmm.
um, like if I do a pre-order traversal, one, which is the root, comes
Mm-hmm.
first in the serialized array,
Mm-hmm.
and that is also how a deserialized array would probably want to see it.
Mm-hmm.
Like it probably want to see this root first.
Yeah.
Um, so if I do a pre-order, then um, so I'm a bit fuzzy right now on like how exactly I'm going to deserialize a pre-order. But let me go ahead and just like run through an example to see if
Okay.
it's viable.
Mm-hmm.
So I'm gonna go ahead and do like one, two. No, it's going to do one, and then it's going to go to two, and two is going to print itself first, and then it's going to try to print its kids.
Mm-hmm.
So maybe I'll go and actually do that. And then once it's done, it goes to three, which prints itself, and then goes to four, which prints itself. It prints its kids, and then it goes to five, and then it prints its kids. So me, a deserialization algorithm, to see this, I make one, and then I know that its kids are two. Um,
Hmm. So
I do one. Yeah,
So the issue lies in figuring out whether or not the value should continue going to the left or whether or not it should move to the right, right?
yeah, yeah. That's right.
What can you use in order to differentiate?
Yeah, I could like add in markers in the serialization. Uh,
Oh, oh, okay, that actually is a valid possibility. But like, is there like any like existing markers?
yeah, like I know that I went in like in order. Like I know that I went in pre-order traversal. So uh,
What do you notice about the sequence?
I noticed that uh, well, I know the left kid comes first.
Mm-hmm.
Um, and then like everything on the left side needs to finish before go to the right side.
Mm-hmm. How do you okay? How do you know whether or not a node ends?
I know a node ends when I have null null.
Mm-hmm.
Um, so I keep going left until I see null null. Um, um, I I keep building left until I see a null, and then if I see a null, I switch to the right, and then so if I see one null, then I know to switch to the right of the current node. If I see a second null, then I know to switch to the right of the parent node. Is that
Yeah,
right?
yeah. You're on the right track. Yeah, but
Okay.
like try not to think about it in terms of like the parent node, and like that sort of thing. Think about it like as like a like how just think about how like pre-order works, right? Like like
Right.
left, right.
I mean, could I just do a uh,
Okay, what are some ways like how do you
I could
do?
just
Oh yeah, sorry.
I yeah, I could just do a pre-order like print. Um like you make the note, you make yourself first, and then you go left, and then you make
Mm-hmm.
like is this just like a recursive function where um it returns if both children are null?
So a recursive function where it returns if those children are null. Okay, that's an interesting thought. What like okay like
Uh
because the goal of the deserialization is to create a tree, right?
right, that's right. Yeah.
So let's say like you encounter like an n. What do you need to return?
Uh or maybe I like think of these as like maybe I'll make it like a very simple example case. So if I have just a null, then I return an like a I return null, right?
Yeah.
And if I have just a one,
Mm-hmm.
um, if I have just one, then I return a node, a node uh, with value one, right?
Mm-hmm. Yeah.
And then if I have like one null null, then one is gonna make a call. Uh,
Yeah. Keep going. Keep going. Keep going.
um, so if this is recursive, or let's use a for loop,
What sort of
I find a
search
one.
like what sort of search can you do?
Is a breadth first search?
Mm, so breadth first search is used for like what kind of traversals can a breadth first search be done for?
For like traversals that pan out, or like level order traversals.
Yeah, yeah. What sort of search would you use for something like pre-order?
Uh,
Don't think too deeply about it. Just like yeah.
like depth first search.
Yes. Okay. Depth first search. Yeah.
Okay, so I just make a depth first search where like on each iteration of the depth first search, it gets the next item in the string and places it there.
Mm. So like okay, like let's say like let's try like going forward with your example for like a one and n.
Hmm.
Like let's say like you call like DFS on like the first elements in like the string, right?
Hmm.
So
So
how
if I have one, so like DFS starts at one. Um, so it places one there, and then it knows to go left. So it takes the next element, it takes the next value and places it there.
uh-huh.
Um, and since it's null, it just returns because it doesn't continue any further.
Hmm.
And then
Well,
so
it
the
doesn't like what is it? What would it have to return?
it would return. Uh,
Like
oh, does it? I'm. I don't think it would need to return anything.
mm, okay, or maybe it's maybe you're thinking of it the right way and I just misunderstanding it. But like take a look at this output, right? Or
Hmm.
like when you want to create a tree, like like okay, sorry. Like when you want to create like a tree, like what do you need to return if you encounter like an n? Like what does that signify?
It means that there's no children.
Yeah. So like okay, you know what, yeah, just keep going, keep going. Maybe I'm nitpicking. Okay, just keep going.
Actually, um, it it returns null.
Yeah,
Let
yeah.
me code this
It
out.
returns null. Yeah.
I think this would make more sense if I code it out.
Mm.
So I would have the research on a node, and I want to do and maybe I store the index. Not too
Uh-huh.
sure. I might get rid of that later.
Mm.
Um, so I'll do if node equal to null, then return none. Node equals to um, actually maybe that's it, and then else. I do uh, am I past a parent? Maybe I am. And then so I get the what the current is supposed to be. Um, uh, maybe I'll get like a serialized version of the curve value.
Mm.
So curve val, I'll default it to none. If it's n, then it's going to be none. Um, otherwise, curve val cur is not with n. Then curve val going to be parsed version of string at I.
Oh, also quick
Mhm.
clarification. Okay, wait, let me quickly. Okay, let's assume this is the definition for like a binary tree node over here.
Yeah, for sure. Um, and then I want to do for valuable tree node where the value is val. And then I want to do um, return, no, left child equals DFS. So I don't know I don't need the parent, I guess.
Mm.
Left child is DFS of I plus 1. And then right child. I already know this is wrong. It's right here. But uh, that's a that's the best deserialize I got.
Okay, okay. I see. So what you have is you have the root and you call DFS with okay, with 0. If
Yeah,
if it's equal like that, you turn none. Otherwise,
I make a
you
node with a value. I get the left and right child, and I return that node.
uh-huh. So
So the problem here is the problem that I've noticed so far is like it just grabs whatever the next two like indices are. But um like for example, if we look at 1, 2, and n, the next two are not its children.
wait, like okay, oh, like wait, which one? Oh, 1, 2, and n here.
Yeah.
So
So like my program assumes that 2 and n are its children, but it's not.
hmm. Wait, for like 1, 2, and n, it assumes 2 and n are its children, but it's not.
Yeah. So the way my program
Oh, right,
works
I see.
is yeah.
1, 2, and n. Hmm. So okay, okay. You know what? Like so why is it that like it's not the children? At what point would you like I noticed like you're incrementing the DFS by like by 1 and by 2, right?
Mhm.
Is there a way you can like is there somewhere in the code which you can increment which can fix this? Like okay, like you're saying like okay, like if we go here 1, 2, 3, the reason why is because like the index is pointing to like the wrong area in the tree, right? Like
Right.
yeah,
So you mean like what if DFS returns like the next index to go to?
like okay, okay. Let's just single out like this specific statement here. Like
Hmm.
would DFS like you said would it DFS I plus one and DFS I plus two work if you were to, let's say, like return like an empty node here?
All right, sorry, I'm confused by the question.
Oh, sorry. Okay. Okay. Let's so for one, two, and n, basically it looks like this, right? One, two, and like n over here, right?
Yeah, that's right.
So in like a regular scenario where like without like the n, like you would have like one, and then two, and then like hmm, like you, okay, so like look at like you have the index pointing first of all to like the first value here, right, to like one,
Yeah,
and then when you
yeah.
call DFS on the left, it does that, right? And when you call DFS on the right, you're assuming that like it goes to like here, but in reality it goes to like some sort of value here, but in reality it goes to like over here, right?
Because DFS makes its own DFS hole. Is that right?
Yeah, okay, so we have like okay, one, two, and three. You like DFS I plus two. What where it should be going is it should be going here, right? But there's two n's in the way, so like the index is pointing to the wrong area.
Yes,
It should be
yes,
pointing
yeah.
to three when it when it's really pointing to this one, because like one,
Right.
two, three. How do we get
So I could
the index to like point to three instead?
like couldn't I have the first DFS call report back to me like when it's done, where the next one is?
Mm, just think about it in terms of manipulating the index. Like like we have one, and then this is two, right? What index would
Right.
this be? What index would this be? And what index would this be? And can you increment the index in order to like have it like match what it's supposed to be?
Oh, I just increment like a global variable for every node that I process.
Yeah, pretty much that. Like yeah, like we
Okay.
global yeah, global variable. Yeah, that works. Yeah.
Okay, okay. So um CX or no, two process zero. And then
Well, you can just make it like you can make it like simpler, right? You're like I, or I guess two process works also, but
yeah, I just wanted to make a variable name that like is descriptive. Um okay, so
okay.
it's
Here, I'll shoot you a question. Do you really need to pass in the index in the first place to DFS
um
if you have a global variable? Can't you just
I guess
have like
not.
a global? Yeah.
Hmm. So I'll do like two process plus equals one. I would want to make sure that like I don't run out. So
Well, oh yeah.
um just return. I'm gonna guess what you were gonna say is that it's unnecessary.
Just keep going. Just keep going.
Okay, okay. Um and then let's see, character is going to be my string at two process.
Hmm.
And then if the character is equal to n, I return none. Um,
Hmm. Well, yeah. Oh well, you return none. Well, like, would you also have to manipulate like the to process in any way? Like,
Yeah, yeah, it does no matter what.
okay, yeah, just keep going, keep going.
Um, well, you said keep going, but unfortunately, this is my solution.
Oh, okay, 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 okay. No, no, no. You're doing really good. You're doing really good. Okay. Um. Okay. So, think. Okay. Like, let's run this through, right? So what you're doing is, okay, you're doing the check, and then for every single one, you're always adding it by one, no matter what, right? Regardless of if
Yeah,
it's
that's right.
none, you move it forward. Okay, you have the right idea, right? Um.
Hmm.
Let's say like you do like encounter, like you do encounter like a value, right? Let's say like, okay, so for DFS, actually, wait, maybe this does work. Hold up. Let me think about this. Okay, so we have one, and then we add two over here, regardless of whether or not it's like a null value, and then oh, okay, okay. So when you create a new tree node value, right?
Hmm.
Like like what are like when you create a new tree node value, you're also incrementing like you're also like, adding a node to the tree, right?
Yeah, that's right.
So would you like wouldn't you want to have to count that as well?
But I already did up here. Don't I? Like
Okay.
whether,
But
yeah,
like
whether I. Mhm.
let's say like you add like this, right? Because like basically like the two process is like the ones that have already been added, like the nodes, right?
Yeah, it's the index that's supposed to be looked at
Yeah.
right now.
So like okay, like let's say like one has like a character is equal to n, and then uh oh wait the okay okay. You know what? This might actually work.
Hold on, let me try. I'm gonna try a online Python compiler.
Okay.
Bro, all I can say is I did not get the job.
No, 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 dude. You broke this down pretty well. I really like the part where you did like n1 and one and n. Like that, like that's a crazy like because like that pushed you onto exactly the right track that I was like thinking of.
Really?
Yeah, right.
No fucking shot, bro.
Like
I did not get the job.
no, no, calf, dude. Like
Oh,
if I saw this problem for the first time, I just feel like I like we're like let's end the Zoom call. Like, no, jokes, but still.
hold on. Fuck, man. Oh, let's see.
Also, is my level of hinting okay? Like, is it
Yeah, yeah, but I feel like I push you to hint like the solution itself.
oh yeah, just like tell me like whether or not I should like lessen it or make it greater. Like yeah, if you need.
Oh no, it's good. It's good.
Okay.
Um, let's go to deserialize.
Hmm.
All right. I'm gonna make the tree node class.
Yeah. You like you pretty much have like the idea like down pat. Like yeah, I think this solution should be valid also for the deserialization. Like all you need to
Really?
do like you need to like know. Well, I guess like you're like I'm gonna reiterate pretty much what you said. Like basically like every time like you see like you encounter an n, you want to return none, and then like increment like the index by that amount. Like that's like the crux of the problem.
Mhm.
Yeah.
Um, hold on. Let's see. What the fuck?
Oh.
Uh, why is it invalid syntax?
Probably indentation.
Um, Isn't it new tree node? Is there no like new statement in Python?
No, there's no new yeah, yeah, there's
Oh,
no
really?
default.
Okay.
Yeah, if I remember correctly, but yeah,
I see. I see.
I got your point though when you wrote it.
Um, mm, come on, bro. Uh, no. Um,
No, wait, what's going on right now?
I'm trying to run it, and it's not doing anything.
Oh shoot.
Okay, maybe I'll let you take over.
Okay. Wait. Like, should I explain or?
Um, could you like hint at what's missing?
No, I think like I'm actually like you. I think you got it. Yeah, you pretty much got it. I think yeah. I think like the way like I was thinking of the implementation is that like you increment by one and then like you return none. Yeah, yeah. Like then you return none, but then like hmm, wait. No, no, never mind. You know what? This is right. This is right. Yeah, I think this is right.
Okay, okay. Let me see if I can get it running though.
Yeah, you just did it in a different way than like I was like used to.
I see. Um, uh, bro, I don't know what is going on. Okay, here's the code that I pasted into the compiler.
Mm-hmm. What's the error saying?
It's not giving me an error. It just like blanks.
Mm, it's not returning any node at all.
Yeah,
Oh,
it
cause
just
you.
like I think it's
Uh.
yeah.
Oh wait, no, never mind. Uh.
Is it an infinite loop? Like oh, it's because I'm not printing anything, bro.
Oh, okay, maybe. Oh, shoot. Okay, no, no, no. Yeah. Well, you already solved this. But yeah, like another thing with like your code from before is that
Hmm.
like in a recursive DFS, you can't like if you have like a two process on the outside, then you have to make it like a global property by doing like the non-local thing. Or another thing you can do is you can surround it in like a list, like list zero, in order to make it like a mutable property. You can also make it a part of the object itself, like a because in like the uh
Oh,
like
you mean like self dot like two process equals zero?
yeah, because
I see, I see.
like within the actual problem itself, like it's all within a class called codec, so it's like
Hmm.
yeah, maybe that's why.
Okay,
But
okay.
you know what, like you got the general gist of the deserialization problem though. Like let's work on
Let me
that.
see if
Okay.
sorry. Yeah, yeah. Sorry, go on.
Like Since you've gotten the general idea, we could also just go to like focus on the serialization.
Yeah,
Uh,
for sure. Serialization should be pretty simple, I think.
mm.
All I need to do is I need to do uh, I just need to do a pre-order traversal. So um,
Wait, where are you typing it?
I'm typing it like at the bottom where it says
Oh,
compiler code.
okay, okay.
Yeah. So I have result equals a string and then def traverse. Uh, Node. Um, Actually, I think I can just do this iteratively. So I want to import not from collections, import deck.
Okay, that works. Why do you want to do it iteratively? Just like to practice?
It's faster, just better.
It's just better. Yeah, yeah.
I
You're right. You're right. Yeah,
mean, it is faster though. No.
yeah. Wait, I thought you used the. Oh wait, no. Maybe I'm thinking of it wrong. Using like DFS, right?
Um. uh,
If
oh
I'm.
yeah,
Yeah.
yeah,
Okay.
yeah.
Okay.
Yes, that's right.
Sorry, I thought I was tripping for a second. I was like,
Yeah. So while the length of stack is greater than 0, opt is going to be stack.pop. And then I want to do result equals opt dot val. Yeah. Um, and then stack.append opt dot left if it exists.
hmm,
And the same thing as well over here,
hmm,
like that.
hmm, hmm. So
Yeah.
also, you would like what is it like what format is the popped value in right now?
It's a node.
Oh yeah, like wait, maybe I'm misreading this. Result. Oh, you would like okay like for pop.val like it would be like a like what type is the val?
It's an integer, but I'm pretty sure like doesn't Python allow this? Like doesn't it?
I don't actually I'm not sure. Maybe it does, but
Actually, I'll just cast it. It's fine.
yeah. Oh, and then also like how would you handle like null cases in the situation?
Oh right. I forgot to do that. Um, if if not opt.val,
Or just yeah,
want to do.
or if not popped, right? If like there's nothing, like there's no node at all.
Oh yeah, that's right. Do that.
Yep, that works. Yep, that looks valid to me.
Okay.
Wait, um, Also, this might be because I don't have a super strong understanding of iterative, but I forgot like for the structure of this, is it better to check like if popped out left and then if popped out right, or is it better to check if like the whole thing exists? Actually, no, wait, never mind. No, you're doing it the right way.
Yeah, it's better to check before because if you allow nulls to go into the stack, then you'd be wasting space because like all you would do is like pop them out anyways.
Oh, I see, right.
Yeah,
I feel like I've encountered this problem with you before. Okay, anyways, yeah,
yeah.
yeah,
No, you have. Yeah.
yeah. Okay, yeah, that's pretty much it. Yeah, that's good. Serialization is good. Also,
Can we try running this?
yeah, sure. Wait, actually, wait. Before you do that,
Hmm.
um, actually, no, wait. This works. This works. Okay, this is assuming every like right now, your serialization is assuming every integer is like a single digit number, right?
Hmm.
I don't I don't think that's listed as a oh maybe yeah
Oh yeah.
yeah
No, you're right. You're right.
it's a constraint. Sorry, I forgot to mention this. I should have clarified, but the constraint is the integer can be between negative 1,000 and 1,000.
Right. I probably just want to like put parentheses around it then, or no? Yeah,
Or
yeah,
you can just have some sort of like delimiter, right?
yeah, like commas.
Yeah.
Yeah, good idea. In that case, I would just do like comma, and then
Based. Okay. Yeah.
like that.
Okay. What happens if like a null value is a very initial one? Actually, wait that still works regardless. It depends on how you parse it in the deserialize method. Actually,
Yeah. Um. Yeah. Let me just do like result, and then actually no. Um. uh, um,
yeah. Random note: I've never seen anyone add the comma before, but like it works. It works still. I just never seen anyone do that.
oh really?
Yeah. Wait, what are you
Shit.
doing?
No, it's fine. And then deserialize. It's just going to. Mm,
It's just like you can use like a built-in function. Yeah, you don't need to.
yeah. So I'll do like what the fuck? Input is a key reserved keyword.
I think it's like input and raw input, like for terminal commands.
Let's see. Dot split
Yeah,
like that.
yeah,
Mm, ah, two processes starting from one. Yeah, to skip the original comma.
yeah.
Yeah,
Base that works. Yeah, that's good. Um, yeah, that's valid. This is a valid solution. I'm
I
pretty sure.
did not get the job. That was so horrible.
No. That was good. You like this is a hard problem. They would usually allocate like an hour for this, right? Like how long do they give for hards? Like
I,
for,
I, I I'm not sure.
like definitely like half an hour at least to an hour, which like you were able to like get through it pretty well. I think.
I see.
Yeah. Okay. Let me. Do you want me to give feedback?
Yeah, for sure.
Yeah.
I mean, like, this was such a. I personally feel like this was such a mess. Like, I
No,
don't
it was
even know
good.
how
It
you
was
give
good. It was
feedback.
good. Um, No, like you did a lot better than I would have. Like straight up, like when I did this problem, I was struggling. Bro. I spent hours on it, like an hour on it or 2 hours.
No, but you gave me hints.
Mm. Okay, okay.
Anyways, yeah.
Basically, yeah. Basic structure wise, it was really really good. I think like I like how you went through three different methods and then like kind of discuss like the trade offs between like back and forth between them. I thought that was really smart. I think I'm also going like to incorporate into my interviews for the future as well.
Uh-huh. Okay.
Um, like yeah, like the structure went well. You explained your thought process, and I like how you chose to do the deserialization first because like you brought that as the more difficult one. I think like
Right.
the where it got more difficult was when you decided to code it up instead of like fleshing out the idea more. But
Right. Right.
I think this can be like either a pro or con, but because coding it out did help you to understand like the process more, right? So,
Hmm.
yeah, I'm not too sure about like that one, but I think that's where like the code began to get a little bit messy.
Right.
Um,
Right.
yeah, in terms of like how you like went about like doing the thing for yeah for like when you said like level order traversal and like stuff like that, like yeah, those are valid solutions, but they would be a little bit complicated. Yeah, I think
Hmm.
so. Yeah, so like, that's why I
Bro,
said like yeah. Oh yeah.
is pre-order traversal exactly the same as depth first search?
Well, okay. The way I think of it, that first search encompasses three types of traversals: pre-order, in-order, post-order. Breadth first search does level order. Like I just keep those two completely separate.
Right.
So every time like someone says pre-order, in-order, post-order, I just think DFS. Like that's it. Like
Oh,
I don't even
I
like
see.
think
I
about
see.
anything else. Yeah. And
Right.
then
Right. I
anytime
get it.
someone says level order, I'm just like okay, like that's like like breadth first search. I'm not gonna think too deeply about it. So like yeah. And then same thing with like
Right.
stack in a queue. I think okay,
Hmm.
like stack iterative DFS. Well, yeah, and then like queue is like iterative a BFS. Like I don't know if this is the best like way to do it, but I just memorized it. So like I yeah.
Right. So this is really just doing a this is doing a this is doing a post order traversal to deserialize it, right? Because it goes to the left all the time before doing it, like before taking care of itself.
Yeah, I think in this case it would be like a post order traversal in order to deserialize it. I guess to make it a pre order, all you would have to do is like move like the creation of this node before that, right?
Right. Right. Yeah.
Yeah. Yeah. Um, I can go ahead and paste what the deserialization method need code has for it is.
Mhm.
That's like literally the same thing. You just implemented it in like a slightly different way. Like I'll show you here. Uh, sorry. Uh, so for like the way you did it is you had the incrementation at the very beginning and you let that like
Mhm.
fall like as you return it, it already occurred. Regardless, you do that. He did this. He
Oh.
incremented by one here, which both of them do the same thing. It's just that his is more like, I guess, clear, whereas yours is more concise. But
Mhm.
both work, I'm pretty sure.
Also, I realized that because I increment first, I would actually need to start two processes 0.
Mm. Oh right, right, okay, yeah, yeah.
Yeah.
And then
Or I could do like I could start at 1, but then I have to like flip these, or I get that character first,
mhm, yeah.
like that.
Also for like doing this, like adding the comma like manually like this works also.
Mhm.
Um, I think you can do it both ways.
Oh,
Another
what's
way you
that?
could,
What's that?
oh, sorry,
What's it? What's it?
yeah. Yeah. Hello. Wait, can you hear me? Oh, hello, hello. Oh, wait, you're not. Oh, wait, can you? Wait, oh, sorry. Oh, hello.
I get it.
Okay,
Yeah,
okay, yeah.
go ahead.
Okay, you good? Okay. Um, yeah. What was I gonna say? Yeah. Another way you could have done the serialization is instead of using a comma, you could also have created a like a list and then appended it at the very end. Both ways work. I think this one is actually slightly more efficient, but yeah, like your way is slightly more efficient. That's another like thing to note. Um, what else? Yeah. Uh,
Wait,
oh,
what do you mean? What do you mean make a list and then append it at the very end?
so for the serialization thing, instead
Hmm?
of like appending it to like the result thing, you could have made this like a list and then like added it at the very end. But I think regardless, it's fine.
Oh, you mean like uh wait, I'm
Like like
sorry,
like
I'm confused.
like you could have had like this result array added like it
Hmm.
added instead of like doing like plus equals, you just do like result at like this index. You add that element, and then at the very end, you could do like result, result, uh, result dot join like comma like that.
I see.
And this way you could have avoided like the extra brain power that would have been needed in order to like figure out like whether like what index to start at, right?
Oh, I see. I see.
Yeah, it's just like another strat.
Okay, okay.
um other things I thought. Oh, the n minus 1 divided by 2 and n minus 2 divided by 2, I feel like that's a legitimate solution. Like I kept thinking about it in the
No,
background.
the
Oh
the,
yeah.
the the problem is I'm pretty sure that's valid for a child going to its parent, but not for a parent going to its child.
Oh, I see, I see. So I guess like
Or is it?
dude, I need to refresh you on this. But
Actually, maybe it is valid.
yeah. But yeah, I don't like yeah, like it's definitely valid, but I feel like yeah, it would have been more complicated. But it would have been really interesting for you to like have created. I feel like in a
Mhm.
legitimate interview, like instead of like me trying to push you towards the solution, like he would have just let you like have free reign on it. So
Which is bad actually, because then I wouldn't have gotten the solution. Dead ass.
no, like you might have if you've given it a time. Like there is a solution. I think it's just more complicated than this one.
Mm, maybe.
Mm. Uh yeah. Other feedback. I think it's pretty good. Also, just like the advice you gave me from before, maybe like to have helped you like with this, you can like write pseudocode. You could even
Mhm.
write like the pseudocode for DFS and then like slowly like change like like parts of like the DFS to make it specific to the problem. I find like that helps me also.
Right, right.
So like when I see like deserialize and I know I have to do a DFS, I just like be like, oh, I'm gonna like code up like a DFS template real quick, and like I just like do that, and then like
Mm,
that's when I begin like changing up the values. I don't know if
like
that's like
starting with a template.
yeah, like I don't know if that's the best way, but that's just like it makes me like feel like more confident in myself because at least like I can code like the template for it, you know what I mean? And then like that
Yeah.
then I could actually focus on the specifics. But yeah,
Mhm.
yeah. Other than that, I feel like you did like a really good job for such a hard problem. Like that's like insane.
No way, bro. No way.
Like you took every single hint I gave you and like you like capitalized on it. You know what I mean? Like you didn't just like because I would have just froze, man. You kept going. You kept going. So I like the perseverance with it. But,
Thanks, man.
yeah. Overall, pretty solid though. I'll go ahead and end the interview, like the what is it, the interview, like the video now. So bye everyone.
Mhm, mhm.
Okay.